and do some of this together. This should be stuff from last night, right? The first page. So if I type in y is less than or equal to, hang on, I need to get there first. There we go. Y is less than or equal to what? Negative 1/5. Now you notice I have to arrow over to get out of the fraction. X minus 2. I should have something that looks like that, yes? Is a solid line appropriate? Yes, because it has the or equals to, okay? Hang on, let me try something really quick. We're not going to be looking for the point where they cross. What happens when I type these in? Has anyone done it yet? Nobody? Okay, get on to slide 4 or 5 with me. So I have y is greater than or equal to negative 5/2 x minus 2. So there's one of the lines. And if I go to the second line and I type in the other one, y is greater than or equal to negative 1/2 x plus 2. What in the world do I have? I'm going to zoom out a little bit so I can maybe see it a little bit better. What do I have going on?
2 lines crossing.
2 lines crossing. What else?
2 different shaded areas.
2 different shaded areas. Now, the solution to the system cannot be stated on a paper. The solution, to the system can only be shown on a graph. Now, if yours is using blue and red like mine is, the solution to the system is the area that is purple. So, if I asked for 2 solutions to this system, can you give me an example of a solution? I want to look at it. What's an example of a solution? And again, you should have this on your graph. 5,1, yes, that's in the purple area. You can see it right here. I wish I could plot it on there. But right there, 5,1 is a solution. Now here's another question. Listen carefully. Give me a point that is a solution of the first equation, but is not a solution of the system. 2, negative 1. How do I know that's a solution of the first one? Because it's in the red shaded area. It's not a solution of the whole system because it's not in the purple shaded area. What is an example of something that is a solution of the second equation but not of the system? Negative 5, 7. Yep, that's right there. It's a solution of the blue equation only, not the whole system. Now, when you graph this onto your paper, I wish I could show it better. When you graph this on your paper, I am not worried about the part that is only red or only blue. I am only worried about the part that is purple. Does that make sense? So some people like to shade both of them fully just for the ease of understanding it. So they can use, sometimes I'll have people that'll use like a yellow highlighter for one and a blue highlighter for other. So that way the color green shows up where it's overlapping, right? Some people choose to only graph the part that is the overlapped part. However you choose to show it is fine. Does that make sense what I'm saying? Okay. So if I were to graph this on my paper, let me pull up my hover cam here. And that is this system right here, correct? So I had negative 2 as my y-intercept, and it went down 5 and over to, let's see, I need to go up 5, 1, 2, 3, 4, 5, and left 2 in order to get my point. And then I draw the line. Solid line, right? And then my other line, by the way, that's greater than or equal to, so technically we are shaded above that line. Okay? Doesn't need to be a super fancy shading, just get the general gist of it. I'm going to use a different color for the other one. So the other one, I need to do a positive 2 as my y-intercept, and I need to go down 1, right 2, down 1, right 2. So I'm pretending like the purple one isn't there so it doesn't distract me because I'm drawing a completely separate line. That's also above, So I can either show it like that, and I can see, as the teacher, I can see what's purple and red at the same time. Or if you want to wait till the end and just not shade in those two parts and only shade in that part, that's fine as well. Okay? It's completely up to you. So if I were to do the next one, which I think is the next slide, but let's go ahead and graph this one. Y is greater than y is greater than 5/3 x minus 2. What do I start off with there? -2. And then I go 1, 2, 3, 4, 5 up and 3 over. And am I going to draw a solid line or a dotted line? A dotted line or a dashed line. Dash, 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 dash. Okay, I'm going to try the shading the other way. This is greater than, so we're still talking about above that line. Yeah? The other line has a y-intercept of 2 and a slope of 1/3, so I go up 1 over 3. And that's going to be a solid line. And when you graph these, that basically leaves you with 4 spots that could be the answer. It could be this little triangular type area that's the answer. It could be this part over here that's the solution or the answer. It could be this part up here, or it could be this part. Where would the shadings overlap if I needed to shade above the red line, that way, and above the purple line? It would only be that area there. So again, you can solve it this way if you want to and just shade the area where the overlapping occurs, or if you shade both, such as this, make sure you're using 2 different colors so I know which area is the overlapped part. Make sense? Okay, why don't you try the next 2? You can go ahead and back onto Desmos. Try the next 2, and then we'll do some word problems in a minute. So the word problems, if you notice, the 2 equations that are given on the word problems, sorry, I'm frozen here, aren't I? The 2 problems that are given on the word problems are not in y equals mx plus b form, are they? Does that affect me on Desmos? Desmos doesn't need it in y equals mx plus b form. If I needed it in y equals mx plus b form, the y is already kind of by itself, so it would be easy to just move over the 2x and I'd be able to graph it. But if I go to Desmos, I can go ahead and type it in. That's not what I wanted. Hang on. I need Desmos. Sorry. Okay, so let me get back here. And I'm on slide, what? 13? 12? 11? Something? Nope. Here. Okay. So I'm going to type in the first inequality, which said 2x plus y, not plus 7, is what? Greater than or equal to 3. Woo, there's my graph. And the next one, 2x plus y is less than or equal to 15. How is that graph different?
Lines are like this and they're shaded opposite.
They're shaded opposite. So the overlapping, well, first off, the lines are parallel. Do you see that? They're parallel. And the shaded region is between those 2 lines. Are both of the lines solid? Okay. So if we're talking about this realistically, we're talking about basketball, right? And I'm going to pretend like I know about basketball. I don't. I come from short people. We don't play basketball. Suppose that you have scores of at least 3 points in every game. This is blah, 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 blah. We need to determine what this graph needs to look like. Now, does it make sense to talk about negative numbers in this scenario? Why not? You can't, you're not going to get negative points in basketball, right? You either get the point or you don't, right? Same with most sports except golf. So if you notice, if you notice on your paper, your graph is more like this, where the axes are kind of like this. Yes? It might be, it's even zoomed in a little further, I think. But you're only seeing basically the first quadrant, right, on your page. Now, if I look back at my page here, let's talk about what these quadrants or what these values are going to represent. X is my field goal points, and we just learned that a field goal is any basket in basketball, apparently. Would that be my vertical axis or my horizontal axis? Is that vertical or horizontal? Horizontal. It says it's the X values, therefore it's my horizontal. So I need to label this. Okay, I need to label that X-axis as the field goal points. What am I going to label the Y-axis as? The free throw points. Yeah? And I'm going to go ahead and graph that on my graph. And I'm going to talk about that shaded region. So if I go back, let me try and graph this really quick. If I come back here, it looks like, let's see, intercept of 3, slope of 2. So here's one of my lines. Yeah. The other line has a y-intercept of what? 15. Mine doesn't go up to 15. Okay. It has an x-intercept of what? 7.5. Yeah. And then up to like 15. It's going to go something like that, approximately. And the shaded region, or the purple part, is between there. So let's try and actually give some meaning to what that shaded region is telling us in this circumstance. Okay? Suppose you have scores at least 3 points in every game this season, and you have a season high score of at most 15 points in one game. How many field goals and free throws could you have made in any one game? Determine 2 possible outcomes. Well, determining 2 possible outcomes is the same thing as saying state 2 solutions, right? So I could have, if I pick this point right here, that point happens to be 2, 7. So if my max was 15 points in a game, I could have shot 2 field goals and 7 free throws, because that keeps me under 15 points, right? Under or equal to, yeah? Any of these points here in this shaded region would add up to a score of less than 15 points in basketball. Does that kind of make sense? Sort of? Any of these coordinates, so even this one, 4, 1, 4 field goal points would be 8 points, and then 1 free throw would be another point, that's 9, that's less than 15, so that's why it's in the shaded region. If I talked about a point out here, that would be 12, 6. I think that's a pretty spectacular player, isn't it? Somebody who can score 12 field goal points and 6 free throw points. It's pretty decent. For me, it'd be amazing because, yeah, like I said, we come from short people. Okay, so go ahead and use Desmos to try and graph, or to graph this one. And make sure you label your axes. X is the hours babysitting. And Y is the hours gardening. Once you graph it, give me at least 2 possible solutions of the area where the shading overlaps. Make sense? Which line? This one? If you put this in y equals mx plus b form, gives you y is greater than or equal to negative 2x plus 3. Negative slope is going to be going down.
Oh, so you're supposed to put it on top.
You don't have to though, because on Desmos, it doesn't, it'll graph it from standard form. Okay, but that's why it's going down. Okay? Any questions about what you're working on? Yes, sir.
So when you graph you have to put in y equals mx plus b.
That's the easiest form to graph it from.
Mm-hmm.
Or you can just copy it off the Desmos graph. Desmos is supposed to show you what it's like, but I want you to have the experience of putting it down on your paper because you need to know what the graphs look like when you construct them by hand. Okay? All right, I'm going to go ahead and pass out the homework also so that if you are done going through the Desmos, you can go ahead and get started on the homework. Okay? Happy studying.